Hello, everyone. Welcome to Puzzle of the Week number 2, where this week the puzzle is The Butterfly Effect by Mr. Menace and Abed Hawila. Uh, this puzzle was just amazing, and so if you saw the stream, I'm sure you are not at all surprised to see that this was my puzzle of the week from this week, because I was so moved by this puzzle. Anyway, I really, really encourage you to give this puzzle a try. There's a link in the description. If you've not done this puzzle or you did not see me do it, I really recommend that you do so before you watch my solve. But I hope you enjoy this video. There'll be more of this in the future. And I should remind you that I do stream Wednesdays and Saturdays. So if you want to come catch all of the fun live, then you can do that. Or if you prefer this format, I'll continue to post one of these a week of a really awesome puzzle that I did on stream. Thank you, as always, to our patrons. If you'd like to become a patron, you can go to patreon.com/ZetaMath. I hope to see you all in the future. Enjoy the puzzle. Welcome back, everyone. Next up, we have what, despite appearances, is a region sumlines puzzle by one Abed Hawila and Mr. Menace combo. So I really have been enjoying region sumlines, and so I just want to remind you how region sumlines work. So region sumlines, by the way, are usually a baby blue color. These are green. I'm not getting into why they are green, but what they mean is that every time this line passes through a region, that collection of digits has the same sum. So the yellow digits have the same sum as the green digits, have the same sum as the purple digits. For this line. And every line is different. So one consequence of this right away is that these two cells are the same digit. Like they're identical digits because of the way that things work. Yes, that. Okay. Let's get started. There's all kinds of stuff going on in this puzzle. So there's lots of sets of 5 digits. And so the minimum 5 digits can sum to is 15. So I need to make sure these two cells sum to at least 15, which immediately tells me that they are 6, 7, 8, 9. And so these are also 6, 7, 8, 9. These cells also are 6, 7, 8, 9 because they're a sum of at least 3 digits. Let's see. Is this 1 going to be useful at all? Let's see. This is at least... Okay, so this is summing how many digits? That is 7 digits. The minimum 7 digits can be as 28. So that means the sum for this line is at least 14. So these need to be at least summed to at least 14. So I think that means these are from 5, 6, 7, 8, 9. That one's not a 5. I also know that the sum of all of these cells is even because it's the same total twice. So these sum to an odd total for whatever that's worth. So the total is 15 or 17. Oh, bet cell. We haven't done a bet cell in a while. Let's put the bet cell there. So the total for this line is 15 or 17 because of parity. And I don't think there's any way for me to record that, but I'm going to try to guess. Alrighty. You can bet 4 11ticles. No one here will judge you. So what on earth am I going to do here? Okay. Same thing happened over here, by the way. These are also summing to at least 28. And so this needs to sum to at least 14, so I can take 5, 6, 7, 8, 9 as the minimum for these. And again, the total here is odd, so it is either 15 or 17. Let's see. Is there something that immediately breaks if I make this 17? Because if I make this 17, there's only one way to do it, which would make both of these 8, 9. Is there a reason these can't both be 8, 9? I don't see one. I am sad to report. Let's see. Oh, Jay has a point. Row 1, 6, 7, 8, 9 pair in box 3. Go in box 3 and 7. I don't know the sum is 15. I want to prove the sum is 15, but I definitely don't know the sum is 15. I'm pretty sure the sum is 15, because if it's not 15, its only option is that it's 17. Yeah, I suspect, as Sam says, that we're going to end up coloring somewhat. Oh, okay. So, sorry. Let's do it this way. Where do these two digits... Okay, I'm going to uncolor these because I don't think this is going to be helpful. Where do these two digits go? No, I could even put one of them on here, can't I? No, I can't. Okay, that's gorgeous. Okay. So these two purple digits, I contend, have to go here exactly in this box. Here's why. If I put one of them on this line, what I'm claiming is that the other 4 digits on this line sum to the other digit, and 4 digits always sum to at least 10. So in fact, actually, these are purple. The purples have to go exactly there. So that's awesome. So there are 2 purple digits over here for whatever that's worth. And exactly the same thing works here. If I make these... Okay, so let's first of all convince ourselves that these can't actually be purple. Because if these were purple, I would ask the question, where does purple go in box 1? And the answer would be both purple digits go here. And so they're not purple. They are yellow. And so as foretold by my guess that they would be different... they are different. And because they are different, the sum is 15. Because there's only one way to make 17. And so that means that these digits are exactly 1, 2, 3, 4, 5. Which now means that these 2 digits are purple and these 2 digits are yellow. Now, that immediately gets us... a few more things. Let's see. Let's clean up there. That's not 1. That's not 1. Oh, one of them could be 17. Right. Sorry. I don't know why I assumed the totals had to be the same. There's no reason why the totals have to be the same. Just, they're not both 17. Sorry about that. Good point that I had chat to catch me. So one of them is 15, at least. I don't know which one yet, if either or both or whatever. Now, oh, they have to have a common digit. Yes, they have to have a common digit because both purples and yellows look at this. So this digit is both purple and yellow. So coloring is not going to work in this puzzle because this digit is both purple and yellow. Wait, sorry, no, this digit is neither purple nor yellow. So there's a digit, sorry, this digit is neither purple nor yellow. So purple and yellow have a digit in common. So one of them sums to 15, one of them sums to One of them sums to 15, one of them sums to 17. So one of them is 8, 9. So this digit is never 8, 9. Oops. So this is 6 or 7. And so the question is, what is the common digit? So if the common digit, so I guess if the common digit is 6, then that's okay, because it can be 6, 9. Yeah, so it's 6, 9, or 7, 8 for the 17, I suppose. Okay, so this is the digit that's not on either purple or yellow. So this digit is going to get the color. Oh, that's right. I'm not supposed to use blue. This digit is going to get the color green. So 1 and 2 are definitely on here. People are suggesting that maybe I look at the fact that green is here and here. Doesn't look helpful yet. But the point is, yeah, as Chip says, one of the yellows is purple. So I want to be super, super careful before I go about my day, because there is an overlapping digit between these. And so that overlapping digit, here's the point. The overlapping digit goes here. That is the overlapping digit. So this is both yellow and purple. And so it is 6, 7, 8, and 9. Because the digit that is in both yellow and purple has to land here. And now the digit that is in both yellow and purple has to be an 8 or a 9. Yep. Garion, no, they cannot be, because one of the totals is 17. The only two possible totals were 15 and 17, and we proved they're not both 15. So one of them is 17. We did prove they're not both 15, right? How did we do that? That sounds familiar. Or did we not prove they're not both 15? Yeah, they can't both be 15, because then they wouldn't have any digits in common, and they need to have a digit in common. So yeah, one is 17 and one is 15. So yeah, I think we did say that, but then yeah. And the point about parity is important. They're both odd in sum. These are much, much, much too large to sum to 13, because the minimum sum of 5 different digits is 15. So they were immediately priced in from the setup to being 15 or 17. And then it turned out that one is 15 and one is 17. But that took a great deal more orneration in order to figure out. Let's see. But wow, that is the biggest thing I have so far found, is that this puzzle is amazing. It's not a 4. Okay. So what are these cells summing to now? So 45 minus 15 would make these sum to 15 each. So these either sum to each being 15, or if the sum is 17, then these sum to 28, and so they sum to 14 each. So these either sum to 14 or 15. Okay, so that's true. So this cell and this cell both see all of 6, 7, 8, and 9. Because it sees all the purples, all the yellows, and green. And although, boy, does this hurt my head because of the overlapping colors, all the purples, all the yellows, and green is all of 6, 7, 8, 9. So these are from 1, 2, 3, 4, 5, and they're not 1. Okay. Tallcat has an excellent point, which is that 9 can't possibly go anywhere but here in row 7. So why can't the 9 go here? It's because if I put a 9 here, the minimum sum I can make these 5 sum to is 19, which is not 15 or 17. So the 9 has to go exactly here, which means there's no 9 here. Which, because these sum to 14 or 15, means that this can't have a 5 on it either. So these are from 6, 7, 8. And they're either 6, 8 or 7, 8, so there's always an 8 here. On this this thing. So there's no 8 over here at all. So these, again, are summing to 14 or 15. I'm not allowed to use an 8. So if I don't use the 9 over here, that's not going to work out for me. So I need to use the 9. And I'm making 14 or 15 with 9. So I can't use the 7. So there's no 7 over here. And so I need to use a 5 or a 6. So these are from 5, 6, 9. Okay. So all good things. So this box is making good progress. There are no 9s or 8s to place over around the rest of the box. And we're going to use a 6 or a 7 here. Oh, actually, I can't use the 6. Wow, that's amazing. If I use the 6 here, it makes 14, but then it makes this also sum to 14. So this has to be the 7, 8. Okay, really, just take a second just to appreciate the gorgeousness of this setting. If I use the 6 here, I make 14, but then this also is 14, which would then make purple and yellow the same. So I don't use the 6, I use the 7. So that sums to 15, and so this sums to 14. And so because this sums to 14, it's got to be 5 and 9, like that. And so we've got just everything sort of firing up. Okay, so now the one that sums to 14, that's the one where these are an 8 and a 9. And so it has to look like that. These are an 8, 9 pair. Oops. These are an 8, 9 pair. Now over here, these need to sum to 15. And so I don't know what that looks like yet. I don't think. Let's see. Okay, I'm not yet going to attempt to think about this. So I do know there's a 5 on this line. I should probably mark that kind of thing. So yeah, this line sums to 15. So this is 1, 2, 3, 4, 5. There is no debate about that. So this is 1, 2, 3, 4, 5. So this is 6, 7, 8, 9 down here. So this is a 6, 7, 8, 9 quad for the column. So these are from 2, 3, 4, 5. That one's not a 5. I'll get to where 8 is in this row. I kind of want to look at other logic first, and then I'll get to where 8 is in this row, because that's assuredly going to be an interesting question. So if I'm making this sum to 17, My question is, how do I do that? And so I either use 1, 2, 3, 4, and 7, or I use 1, 2, 3, 5, and 6. Those are my options. Okay, I don't know yet. Okay. Yeah, these are 6, 9, or 7, 8. I agree. Uh, right. Okay, and so now the other 8, 9 in row 2 is here. Good point, Medi. So this is definitely purple. It just might also be yellow. Uh, sorry. No, this is the purple digit that's not yellow, because that's the purple digit that is yellow. Okay. So that's a 6, 7, 8, 9 quad in this column. So that means that these digits are from 1, 2, 3, 4, 5. That one's not a 5. Okay, so now these are at most 5, 4, 3. I guess that's not that bad. This digit has to be at least 3. That's not so bad. Okay, now we can look at 8 is on one of these arrows with a 1, because one of these two cells is a 9. That's the only way it works. So the 8's going with a 1. So in particular, these aren't 1. So one of these is 1. That's the point that people are looking for. So there's a 1 over here, and so there's a 1 placed here by Sudoku. So this isn't a 4. 2, 3, 4, 5. Yeah, I know one of these two is a 9. I'm again reluctant to pencil mark this. And then the tall cat thing of like just keep pulling. So now we've placed the 8 in this row. Where's the 7? And so now the 7, because these two arrow circles see each other, the 7 can't go on the other arrow because it would need to sum to 9 because the 1 is taken. And so I can't put the 7 on one of the arrows. So this is 7 is tall cat's point. So there's no 3 here. And so now 7 is the digit that's not yellow. So yellow is 6, 9. So we actually now get that is an 8 and that's a 9 for free. I feel like the colors are useful for me to look at, but they're also going to trick me. So I'm just going to ask chat to not let the colors trick me. Okay, so then you get to just keep going. Where's the 6? And so now the 6 has to go in here. It can't use the 1. So the 6 has to go with a 2. And so this is an 8, 9 pair. These are a 1, 8, 2, 6 quad. So these aren't 2. That's a 3, 4, 5 quad. So this isn't 4, and that's not 3, 4, or 5. This is an amazing puzzle. This is just... it's like showing off at this point. Let's see. So... Okay, so the 7 could be up here, but it could also be up here. I don't know yet. Let's see. Okay, so there is an 8 on one of these. I have to put an 8 and a 7 on these lines. I can't put the 8 and the 7 both on the same line. So this has to be a 7 or an 8. Uh, there's no choice. Uh, and once this has to be a 7 or an 8, the rest of the digits have to sum to 7 or 8. Namely, they have to sum to the other one. I guess that doesn't... That feels huge, but I'm not sure that it immediately helps as much as I had hoped. So let's see. So the... Oh, I guess my problem was I thought this digit was going to have to be big anyway. Sorry, I was thinking this digit was under a lot of pressure, but it was under pressure to be big, and lo and behold, we have shown it is big, and so we have not learned anything. So there's a 7 or an 8 here, but I don't think that really matters. Let's see. Garion says you can't put 1 8 in box 9. Right, you can't put 1 8 in box 9 because that would make this a 9 and make that an 8 and repeat the 8 in the box. Gorgeous. So this is a 2 6. This is a 1 8. So that's the 9. That's the 8. That's the 7. That's the 8. That 9 looks down here and sees that's a 6. That's the 9. Great spot, Garion. Where am I putting 6 in this column? Can I possibly put both 5 and 6 on this arrow that sums to 14? 5 and 6 would be 11. I would need to put a 1 and a 2 on it. I guess I could put a 1 and a 2 on it, in theory, sadly. Okay, well, that's tragic. And now we know where the other 7-8 is in box 4, because we have a 7-8 hidden pair here, owing to the fact that there's both a 7 and an 8 there. So this sells a 7, that sells an 8. These now need to sum to 7, so they are not 3, and that one's not 5. They're 1, 2, 4. This one isn't 1 or a 2. This one's not 1 or 2, it's 3 or 5. That's the other 3, 5. We've got a 1, 2, 4 triple in the row. So that means that these cells are a 3, 4, 5, 6, 7, or 3, 6, 7. That one's not a 7. That one's not a 3. Let's see. I still don't know if 7 is on this line yet or not, but I'm thinking about it. It is something I would like to know with my life. Let's see. I can fill in these 4 digits. That might be helpful. Let's see. I need to put a 1 in here. We've got a 2. We've got a 3. We need a 4. We need a 5. We got a 6, 7, and we need an 8. So that's not a 4. These aren't 5. So yeah, one of these two is 5. I don't know which one. Let's see. Three, 5 here. Okay, so yeah, so I need a 6 or a 9 in this row. It has to go in one of these 2 cells. If it goes here, it has to be a 6. In fact, actually, what are these 2 digits? I should fill that in, because I can. There are 3 and a 6. Those are the digits that go in those 2 cells. And there we go. Now, sorry, these 2 cells are a 3 and a 6, except there's a 3-5 pair that looks at this one, so that's a 6 and that's a 3. So that's a 9 and that's a 6. This row still needs a 1 and a 2, so this is a 1 or a 2. This box now needs a, let's see, it needs a 1, a 2, it's got a 3, 4, we need a 5, we got a 6, 7, 8, and we need a 9. So these are from 1, 2, 5, 9. That one's not a 9 at least. Let's see. Yeah, good job if your bet's still alive. We've got a lot of pressure over there. Let's see. Uh, Apologies, I'm not looking at chat more. I'm just enjoying this puzzle too much, and I keep getting sort of just sucked into like wanting to just stare at it because it is so jaw dropping to me. Uh, let's see. So yeah, so where's the 6 in this box? The 6 in this box is here now, uh, because of Sudoku stuff. Uh, so now the 6 is up here in one of these two cells. So 14 minus 6 is 8. So I need the other two cells here to add to 8. They can't use a 5 because the 5s are gone. So that means the 2 is definitely over here. So it's either 617 or it is 6. Wait, no. It is 617. That's the only option. It can't be 626. And it can't be 625, sorry, 635 because of the 5's there. So this is in fact 617. That's the only option. That one's not a 6, however. So that works. So that means these digits I could just write in. These are a 2, a 3, a 4, and a 5. That one's not a 5. So 2, 3, 4, 5 does indeed total 14. So good for us in that regard. This is not a 7 because there's a 7 in the row already. This is a 2, 3, 4, 5. No, I don't know that. Sorry. Don't listen to me. This I know is a 2, 3, 4. This is a 2, 3, 4 because it can't be 1 or 5 just because of row stuff. So good things there. So now where is 1 in column 4? 1 is placed in column 4. It can only go here because of that big, cool deduction. So that's a 2. That's a 4. The bet cell is a 1. So hopefully you bet 1, as I heard someone say. So that's a 2, 4 pair. That's a 1. Let's see. So, okay, we got that going on. So what else do we have now? Okay, so let's clean up. So that's not a 4 anymore. Let's see. We need a 1, 6, and a 7. Oh, there's an 8 here, looking down at that 1 and that 8 for who knows how long. So that 1 looks up there. That's a 6. That's a 7. That's a 1. So this column is now a 4 to finish up. So that's not a 4. That's not a 4. It's a 2 or a 3. This box to finish up needs a 2, a 3, a 5, 6, and we need a 7. So 2, 3, 7. This one's not a 3, so it's a 2 or a 7. Let's see. The question is, will we at any point ever realize that we used the givens? Or are the givens just there as sort of like a joke, if you will, that like they just like randomly make things resolve? I often, when I use givens, do the givens just randomly make things resolve in a way that no human will ever be able to fully understand. Okay, so there's no 7 on this 15 line anymore. So it's not 1, 2, 3, 4, 7. It's the other one. It's 1, 2, 3, 5, 6. So these digits are the ones that aren't among 1, 2, 3, 5, 6, which are 4 and 7. And we know the order. So there's a given being used. That's a 7, that's a 4, so that's a 6, that's a 3, that's a 7. That's 6, that's a 2, and that's a 6. Let's see. These aren't 6 anymore. That one's not a 3 either, or a 2. It's a 1 or a 5. It's not a 1 either, so it's a 5. These are not 5. Let's see. So that's not 5 either. That's not 5 either. These aren't 1 either because there's a 1 in the row already. So one of these two is 1, so that's not 1. Let's see. This 4 looks down and says that's not a 4. Let's see. Oh, that's not a 1 either because there's a given 1. So that makes that a 1. More use of the given digits. Okay, something is wrong with my pencil marking in this column. The thing that's wrong with my pencil marking in this column is that it's got an 8 in it. So that's a 4. And it's got a 3 in it too. So those are a 2-6 pair. So that's a 5. These aren't 5. They're a 2-9 pair, and the order is resolved. So that's a 9, that's a 2. The 9 looks up, that's an 8, that's a 9. That 2-6 pair means that's a 3. Let's see. I'm missing something. Okay, so that's an 8. That's a 5. That's a 1. So that 8 looks over and gives us a 7 and an 8, which gives us a 2 and a 3 and a 7. 2 looks up here and gives us a 3. So these aren't 3. So let's look over now. Let's finish it. Okay, so what is this? So this is 2, 4, or 5, I think. I can legitimately say I am very sad this puzzle's almost over. I want another one. Let's see. There's a 3 in this row already, so that's not a 3. Oh, I think I pencil marked something wrong. Because I think I missed a 6 when I was pencil marking this row. Oh, maybe not. Yeah, this I think this is mispencil marked. I don't think anything else is wrong. I think this is actually 2, 4, or 6. Oh, but it's not a 6 because there's a 6 in the column. So that's a 2, 4 pair. So that's a 6, and that's a 2, and that's a 5. That's a 3. That's a 5. That's a 4. That's a 2. That's a 4. That's a 2. That's a 5. That's a 4. This is not a 4. This is not a 4. Actually, I probably know what this is. It's probably a 3, and that's a 5, and that's a 3. Let's see. The 1 over there gives us that's a 2, and that's a 1. The 2 here gives us that's a 4, and that's a 2. And that's a 6, and that's that puzzle. Holy shit. What a puzzle. That is amazing. Has this appeared on CTC yet? I admit I have not checked every day, but I don't think I've seen it, and this is like the most amazing puzzle I've done all year. They should definitely they should definitely do this one. If they have not yet, because whew, wow. Yep, I am at a loss for words. It's okay. It's the other Sudoku streams that are family friendly. I don't have any family friendly promises on my stream. That is why I curse so often. Yep. Not much more to say about that other than whew, woo boy. Alrighty. After I pick my jaw back up off the floor, we're going to do one more puzzle.